Hello, so today we'll be going to do the medium question of this today's daily question of minimum score triangulation of polygon. First, you have a convex n-sided polygon where each vertex has an integer value as shown over here. You will be given an array of values where values of I is the values of the ith index in clockwise order, which I will show in the example later on. And then we will triangulate the polygon, and then for each triangle the weight is just basically the product of all of the values of the vertices, and the total score will be the triangulation of the sum of these weights. So to understand this question, firstly, to form a valid triangle, I, which is the first vertex, must be less than k, which is the second vertex, which is also less than the last vertex of j. So what this means is that when we first pick a point of I and j, let's take this example over here, 1, 2, 3. It will be 1, 2, and 3. So this is just basically a triangle. The index here will be equals to I equals to 0, I equals to 1, and I equals to 2. So the condition of I less than j less than k, of less than k less than j must be fulfilled over here, such that if this index of 0 and 2, 2 minus 0 is less than 2, this triangle is not valid because it will just simply be a straight line. That's why over here we will have the first base case is that there's no triangles being formed. So if I minus I is less than 2, we will just return 0. So the first instinct of doing this question will be doing recursion function. Hence we are defining dynamic programming inside it. So we'll first define dp bracket taking the parameters of I and j, and the base case will be as shown over here. And we must keep track of the result of this total score. So we'll set it to become float of infinity. Since it's the minimum, we can set it to infinity. Likewise, if they want maximum, it will be negative infinity. So now we have two vertices of I and j. So for k, it will just be I plus 1 right before j. So to understand this better, it will simply be this. I'll be using this second example of 3, 7, 4, 5. So 3, 7, 4, 5 will just simply be a square or a rhombus. So the first value will be 3 in a clockwise manner, 7, 4, and 5. Now just write the index on top of it for clarity. 0, 1, 2, and 3. So to understand this, we will take I and j at one of these points, as well as k. So for this, let's say we choose 0 and we choose 3, basically the first index and the last index of this list. We cut a line in between here. So this just means that we can choose a value of k in between 0 and 3. Basically, as long as this index number 1 or 2, it will be valid. So if we cut here, this will be the line separating, and as you can see, we will have two different polygons. So to find the polygon, since this is I, and then this is our j, to solve this, our k can take in any value of this 7 or this 4, as long as it makes sense. That's why we have this for loop over here where for k in range of I plus 1 and j, and total will be equals to the value of I, basically the product, and we'll use the minimum where we'll find this. So what's the total is simply just this. So you might ask, why do we need dp of bracket ik and dp of kj? So that's the magic of this question. We will be calling the function within itself, and it will be called recursively and solving it. We will add a cache at the top of here, such that if similar parameters are being input, the function can capture it without recalculating it, saving memory space. So right over here, we'll be calling it dp of ik and dp of kj. So to understand this, we'll go back to the drawing again. So dp of ik will simply just be I and k. So if let's say I put a value of k over here, I will find all possible triangles between I, k, which is this triangle over here. Okay, and then once I find that, that is dp of ik. So what is dp of kj? It will simply just be this, the values of k to j, which in our case is not valid. So finally, the last step will just be simply calling 0 to the length of values minus 1, which is the last index, and we'll submit it. And that's it for today's question.